Let's get to talk about MLOps. If you get to go and talk about MLOps participants, you will get to see two keywords get to rely on this. We get to rely on two keywords. One the ML and the other one is ops part. So as you are aware that ML stands for machine learning, where we get to go ahead and train our machines to generate the models, to create the models. And op focuses on deploying those build models. I get to go and focus on what? Build, deploying the build models by bringing them to what? Production. So I get to go and develop the models here. And what I get to do is that I get to go and deploy those models. So participants, the simplest and easiest way for me to get started is to get to break down this MLOps instead of not looking at just as a new subject. Break it down into two parts, which you are already aware of it, where ML focuses majorly on model development. You are developing the model development. Rest, the ops part focuses on how fast you can get to deploy that model to production environment. This is the easiest way for you to connect with the dots of MLOps. This is not a new subject at all. Just wanted to go ahead and confirm you participants. We already have a lot of organizations who are focusing on developing their own models. And ops teams get to go ahead and help those built models to bring as fast as possible reliable methods and proper models into production environment so that they can get to go ahead and connect with those built models and make it to serve the people. Okay, I know things won't make it very clear. I'll get to justify it, participants. There has been a research done by a company where they did get to go ahead and understand that why there is a need for this strategy to be followed. There is a consortium, that means a company or an organization with the same name, ml-ops.org. So what they have done, they did a survey that what is this motivation that gets to drive this MLOps. So when they have done a survey participants, I'll get to open up this image. So they have seen there were two set of people, one who were data scientists or data scientists in general, and the idea of they building the models and getting those models deployed. So what they have done and what they were able to understand is that these data scientists had a common view. What is that common view? They say that they develop this model today, and after a quarter or more than a quarter, like about 3 months to 4 months, they were just waiting for that model to get deployed. So this image that I just did get to bring here, participants, they found out that the data scientists spend good amount of time to build the model itself. Imagine if a data scientist takes to build a model 3 months. So another 3 months will be required by the ops team to get to go and deploy the. In nutshell, that means just to release the first version of the model V1, we are required to go and spend 6 months just to release that model, the version of that model. So this will really hamper the kind of deployments that we get to focus. The kind of development time to the deployment time will get eventually impact the kind of performance of your model itself. Because over a period of 6 months, a lot of things will get to change. The data gets to change. As the data gets to change, the performance of the model gets to get degraded. So the aim is how fast can a developer code can turn into a model and that model can get to deploy into production. So they're trying to find out the best model out of the models that they get to build and the best way to deploy that model. So the summary of this image, which I have just shown you, gets to highlight that a lot of amount of time gets wasted for focusing on deploying that model. So data scientists spend nearly quarter or more to get their models deployed. So I hope participants, my point is conveyed clearly to all of you. What I wanted to convey, the one thing that I wanted to convey was model development itself is time consuming. On top of it, another set of quarter or more is required to deploy that model. So how can we come out of this process? So how can we make this process in such a way that it is thoroughly streamlined, where we can get to code and release continuously the making of changes that they get to code and do as part of it. That's where the very interesting subject of DevOps can help you. Before you jump into MLOps, you should get to have a little idea about this DevOps. I'm assuming that most of you are aware of it. If you don't, participants, DevOps is a strategy you can consider that companies get to utilize for their continuous integration and continuous deployment. So what does it mean? It means the changes that you get to code and make in your source code, you will make those changes continuously integrated and continuously deployed via this DevOps strategy. So this DevOps strategy will be brought up to machine learning code now. So what they will get to do, machine learning code plus the DevOps skills put together brings us the perfect definition for our MLOps, everyone. Hope this sounds very clear to all of you people. So now participants, you are slowly adapting how the ops team will get to go ahead and address the MLOps. They will get to go ahead and bring the concepts of DevOps engineering. So now let me move a little further that how the concepts of DevOps will be utilized into the MLOps engineering. So participants, it is all that when you get to start, they get to go ahead and focus on model development and addressing the kind of models that they get to build to deploy those models. So the ML engineers will get to start the model development, and the ops engineer, as I mentioned, they'll get to focus on deploy that model. So if you get to move onto the right hand side, you see there is an image that I did get to place it for you. So participants, this part of the code you can break down, or this part of the image you can break it down into two parts. One part here and the other part here. So what I get to see this part, participants, is that I get to go ahead and focus on developing the model. This is my development, or instead of word development, let me get to go ahead and use ML part. I get to focus on addressing what participants, the ML part, machine learning. And this part focuses on ops part. What goes inside a machine learning? The data that is required for us to consider. That means I bring the data. Using that data, what I get to do, participants, I develop. What is that I'll develop? Model. If I feel that the model is not good, I get to go ahead and retrain this model. That means I get to make necessary changes in that code or the data that I get to have a proper model, which is the best model by my iterations, best model. Assume that I got the best model, I give it to my ops team. My ops team will get to review it, get to focus on deploy it, and make it available for the people. That means end users can get to use it. The users who are on the internet get to use it. They get to go and give some recommendations, changes, inputs, which I get to go and consider, and I will give it back to my development team. That means my development team is expected to bring them as part of new features. I have to bring it new features. So this process now becomes in a continuous loop. Model development has taken place. I got the best model. I gave it to ops team. They deployed it. People are using it. New features are expected to come, and we continuously develop it. So this process cycle continues, and that's how participants MLOps is made possible, which was not possible earlier. That means model development is happening, and the ops team is continuously deploying it. Now, because of this, what are the advantages that I'll get? The advantages that I'll get is human involvement is almost zero here. There is no person that is required for me to automate this process. Via this automated process, I don't need to involve humans. Next important thing is I make the release faster. I don't get to go and make this becomes faster way to release my product. I don't get to rely. I don't need to wait another 6 months. I can just get to release in the next 2 weeks. Why? Because the latest model that I get to hold, I'll get to deploy it and see whether it is working. If it is not, I will just get to go and give it back to my development team. If I get the best model, I'll release it. Any changes, I'll get to more gig. So the time that was taken for this model that were earlier taking months now has been brought to days. Participants, after this pointers, what I would like to bring is your attention. Okay, instead of jumping directly onto this topic because it will be little challenging for you. Participants, what I'll get to go ahead and break down is I'll get to go ahead and give you a very, very high level, which I want you to memorize. What is this high level? The stages that you get to see. These stages which I want you to understand, memorize this. What are those stages? You will understand a problem, you collect the data for it, you address necessary changes in your data, you get to focus on developing the model, and you get to go and deploy this model. Essentially, MLOps can be seen here by handing over the best fit model to the ops team, getting to go ahead and hand it over to the delivery. That means for the deployment, I get to go and deliver it and I get to deploy it at an endpoint. So participants, this is where I get to go ahead and see the MLOps coming into picture, which I want you to memorize in the form of stages. Very much easily you can memorize. You will address the problem, get the data, make the necessary changes. Essentially, this is part of data engineering task. The data engineering team will get to go ahead and focus on it. The data scientist team will get to go focus on building the models, training the models and getting the best model and focus on deploying it. This is where the DevOps team you can consider coming into picture. Data engineering team, data science team, machine learning team, DevOps team getting all work together under the umbrella of MLOps. That's fine. But now the question will come back here is how will you decide which model is the best? Correct? Participants, in this cycle, if you get to go and move a little further here at this juncture, I'm telling every time model, model, model. Which model that I'm talking about? Is that the model with the highest accuracy? If I release a version, I want to get to see which model has highest accuracy. Or model version 2 I have released, which has least errors that are associated with it. What is that best model? So my management team definitely will get to go and ask me that, hey, how Siddharth is that you are deciding that you are getting the best model? We want to get to see that model. We want to get to see the metrics of that model. Participants, I'm promoting that I built the best model, right? So you might ask me, hey Siddharth, how do you get to say that this is the best model? I should have something recorded, right? That I trained the data, I got the outcome, I see this is the model, which is best. I do train another data set, I got the model. So if I get to go ahead and use a data set and I train that model, if I get score, accuracy score is somewhere 80% for the first time. Next, I attempted another time, the score went up to 79. Can I say the version 2 code, which is at 79, is the best model? Participants, can I get to say the version 2 of the code that I have released is the best model? Because 80 is the best score when compared to 79. So I cannot say that I'll get to have the best model for every iteration. So I need to go ahead and make sure in order to get the best model, I am required to go ahead and consider participants recording such information. I need to record that information. Record in the sense, what is a data set? Siddharth, you used? What has been your features? What is your score? I need to map them. For every iteration, first time I attempted, I got the scores. Second time I attempted, I got the scores. Third time attempted, I got the scores. Now I have to show to my management that management version 2 was the best model that I should get to go ahead and use it because I got best features and best score in that scenario. You're getting the logic, participants? So I have to get to show to my team that this kind of approach that I followed has helped me. Let me give a simple example, participants, to connect the dots. If I just get to go to and use, model performance metrics, you'll get to have a connect with this. So what they do, they get to go and verify which model has features that it is getting recorded. So model performance metrics scores. I get to go and generate the scores for it. So what are the scores that I get to evaluate? Root mean square error, AOC, accuracy. These are all this metrics that I get to record against one model over the other. Participants, don't get into the all details. What I'm trying to tell you is, if I need to evaluate my model, there are tons of metrics that I can record. But all these records have to be verified for the next iteration. You're getting the logic, everyone? Today you're recording something. Today you're recording maybe say accuracy, F1 score. For the next iteration, that means for the next run, what is that you get to have? F2 score, or sorry, F1 score. So how do you compare it, participants? So I'll get to give you a library called MLflow. MLflow can get to record that for you, participants. In machine learning, we get to go and use it something called MLflow. What does MLflow do? Here is a perfect example of the MLflow, what exactly it has to do. So in this, participants, you can see it has recorded information about the scores. See, every run is being recorded here. The scores you can see here. And also, participants, if you get to go ahead and look at little more, you can even get to see which are the models that had great scores. Based upon that, you will get to find your best model. Why did I get to go and use this word again and again, participants? Because you are supposed to go ahead and find that model which has the metrics that you have decided. Maybe I want to go ahead and decide that score. The score is I have to have the least RSME, least errors are expected in that model. So I get to pick that least model error. So I see the one with the least error is somewhere around 0.070. So I get to pick that and consider that model as my best model. So in this example, he has given that 0.809 is something that he's going with, and he's picking that model, which is to be considered as the best model. So what they get to do, they get to go ahead and take that best model and they get to go ahead and transition into production environment. That means they will move from one stage, which is testing environment, to the staging environment. Don't worry about it, participants. This topic, I'm not focusing on the all capabilities. I'm just giving you an example that when I have tens of runs associated with me, if I have run the model for 10 times, I get different scores for every 10 times. So how do I get to see out of the 10? I'll get to pick that best score. This is the best score I got, and I'll pick that model which I get to use it for the deployment. Now you have understood that you will get to go and pick this model. Now the question is, if you are getting to go and pick that model, and if you get to go ahead and deploy that model, where you get to go and deploy it? There should be a place where you should get to deploy it at, right? So what they generally do, participants, is that they get to go ahead and first thing is register that built model. They get to go ahead and register that model. That means out of 10 versions, I found the best model, I registered that. In this example, he has registered that model. After registering, you can test it, but participants, things should go beyond testing from local environment because we do not rely on local environment. We rely on cloud. We get to go and rely in a cloud practice. So participants, in order to go ahead and deploy in a cloud practice, you have majorly three cloud providers in the industry. I hope everyone are aware of the cloud providers. The cloud providers get to go ahead and focus on what? Or if you get to see the list, AWS, Microsoft Azure, and we get to go ahead and use GCP. These are the three top cloud providers we host to address this requirement to deploy our models, AWS, Azure, and GCP. Now imagine participants, I get to go ahead and use AWS cloud. That means I have to build my model relevant to AWS, model underscore AWS. If I have to build model for Azure, model underscore Microsoft Azure, model underscore with regards to GCP. That means same model, I have to change code to three different cloud providers. That's going to be challenging, right? Tomorrow, if I have to make commits on 10 commits on a day, that means I have to maintain totally 10 commits multiplied by three cloud providers, 30 versions of the code, 30 versions of the same model code. Practically, it's going to be challenging if I get to go and follow this approach. The idea is, can I get to go and deploy one model that can get to go and work in any of these three clouds, whether it is AWS cloud, Azure cloud, and GCP cloud, and any other cloud? Participants, that is where containerization will come into picture. What is that containerization? Your model gets containerized in the form of a image, Docker image. And that is the reason, participants, you might have noticed it is focusing on building a container image for your model. That means your model will now get turned into a container image. That container image we get to go and deploy into various cloud practices, participants, right from AWS, Azure, and GCP. One Docker image is one container image is sufficient for us to run it in AWS, Azure, and GCP for our built model. Let's say our built model is model X. I built a model X, which is a container image. I can deploy it in AWS cloud. I can deploy it in Azure cloud and GCP cloud of containerization. But participants, how does production grade containerization come into picture? Production, now I'll show you. Production grade containerization, if I have to consider, there is no subject that can match up the skill set of the following subject that I'm picking up for you participants. It is none other than Kubernetes. Kubernetes is the production grade container orchestration platform which organizations use for their model deployments. That means for their container images. And that's how participants you will make an entry into Kubernetes. Now that image is available for your application that can talk to your model, then Kubernetes do come into picture, participants. That's how Kubernetes comes into picture. Since Kubernetes has come into picture, then the Kubernetes community felt that they should also get to go and offer the industry or the community of Kubernetes who get to go and use it a container orchestration that should help them to address MLOps. And that's how participants, the subject of Kubeflow has started. That means companies have been able to get to go and address production grade deployments in Kubernetes. That means if Kubernetes has to extend their support towards community, what they decided is if they want to go and address MLOps, they brought up this concept of Kubeflow. So what you can expect from Kubeflow? Model registry, model development, containerization. You can get to go ahead and build your models and turn them into images, model development, and essentially the MLOps put together. So let me connect the dots now. So I have highlighted about MLflow. Now I'm highlighting about Kubeflow. So if you get to go and look at the Kubeflow and the branding of it on the Kubeflow participants, it is essentially subject that is brought up by the Kubernetes community to address what? So, to address the ability of you building machine learning models and MLOps on Kubernetes platform. That means if you decided to go ahead and use Kubernetes platform, you should get to go ahead and connect with Kubeflow. So that's how participants, the concept of Kubeflow has started, and a lot of companies today use Kubeflow, and also participants, they get to go ahead and use MLflow for their model development, registering, hosting of their models, comparing of their models, and also get to go ahead and use Kubeflow if they are running in Kubernetes environment. So now participants, what is that what exactly did I get to go ahead and bring connect here, participants? The connect I'm trying to bring is, participants, in production grade scenarios, you will get to see Kubernetes coming into picture because there is nothing to map the ability of Kubernetes. So if a company X company involves model development and get to go ahead and focus on using container orchestration, you will get to heavily rely on Kubeflow. At the same time, participants, now you want to get to go ahead and record that information about the model development and register them, you will also get to use MLflow. So participants, MLflow and Kubeflow has been game changer tool for our consideration of MLOps. So if you have decided today, participants, to get start your journey with MLOps, welcome everyone to the world's most popular tools, Kubeflows and MLflow.